Hey everyone, welcome back to the channel. Today we are diving into something that's become a cornerstone of modern data-driven businesses, data streaming architectures. In this video, we will focus on how you can leverage AWS to build a modern data streaming architecture that ingests, processes, and analyzes high-velocity data streams in real time. This architecture is designed to deliver reactive, scalable, and intelligent customer experiences, making it ideal for applications where responsiveness and real-time analytics are crucial. We'll break down this architecture into 5 logical layers, each layer serving a specific purpose. By the end of this video, you will understand how these components fit together to form a robust and highly scalable streaming solution on AWS. Let's jump into the first layer, the source. The first layer of any streaming architecture is the source. This is where your data originates, and it typically consists of IoT devices that continuously generates data. Think smart homes devices, wearables, or industry sensors. It can also include web and mobile applications that generate logs and metrics. Social media feeds providing unstructured real-time data, machine logs, and mobile devices that produce semi-structured data streams, clickstream data from users' interaction with web pages. The key characteristics of the data generated by these sources are that they continuously and arrive at high velocity. The data is often semi-structured or unstructured, requiring real-time ingestion and processing. In an e-commerce system, your application might track user behavior in real time. Every click, every search query, and every purchase event. That data can be ingested and processed to generate actionable insights like product recommendations and dynamic pricing. The stream ingestion layer is responsible for collecting data from your sources and feeding it into your system in near real time. On AWS, there are several services to consider. Amazon Kinesis data streams for high throughput data ingestion from a variety of sources. Second, there is Amazon Managed Streaming for Apache Kafka (MSK) for Kafka-based workloads. Thirdly, there is Amazon Kinesis Firehose for loading streaming data into services like Amazon S3, Amazon Redshift, and OpenSearch. Fourth, there is AWS IoT Core for IoT devices data ingestion. And lastly, there is AWS SDK and Kinesis Agent for custom data ingestion pipelines. For IoT use cases, AWS IoT Core can directly ingest data from millions of devices into Amazon Kinesis or Amazon MSK. For change data capture use cases, you can leverage AWS Data Migration Service to stream changes from a relational databases into the data stream. This ingestion layer is highly scalable, capable of handling data from tens of thousands of sources simultaneously. For a robust ingestion strategy, ensure you design your high availability and fault tolerance. Using services like Kinesis Agent can provide automatic retries and buffering in case of network failures. Once the data is ingested, it needs to be stored temporarily for processing. The stream storage layer ensures that data is stored in a scalable and cost-effective manner. It provides the ability to store data in the order it was received for a set duration and allows replay during that time. On AWS, you have multiple options for stream storage. Firstly, there is Amazon Kinesis Data Streams, which stores data for up to 7 days by default, extensible up to 365 days. Secondly, there is Amazon MSK, which is the managed streaming for Apache Kafka. which offers fully managed Kafka clusters for long-term stream storage. Thirdly, there is Apache Kafka on Amazon EC2 for custom, highly tuned configurations. In this layer, you can store data for processing in real time or batch processing at a later stage, depending on your architecture. As a best practice, you should always configure data retention policies that match your use case. If your application needs to process data within minutes, a shorter retention window could optimize costs. The streaming process layer is the heart of your architecture. Here, you'll process the incoming data in real time, transforming it into a state that is consumable by downstream services. AWS offers various tools for processing. Firstly, it offers Amazon Managed Service for Apache Flink for advanced stream processing, allowing for stateful, fault-tolerant, and exactly once processing. This is perfect for use cases where you need complex event processing and enrichment. Secondly, it offers AWS Lambda, which is great for event-driven, stateless processing. If you need to enrich or filter data in real time, Lambda can trigger based on new data entering your stream. Thirdly, there's Amazon EMR, which is useful when you want to leverage open source big data frameworks like Apache Spark for stream processing. And lastly, there's AWS Glue, which can be used for ETL jobs that combine both batch and stream processing, making it versatile for streaming jobs that involve event-driven pipelines. Processing data in real time allows businesses to react to events as they happen. For instance, detecting fraud in financial transactions or processing user activity to deliver personalized recommendations can be done instantaneously. One pro tip here is that you should always think about scalability and throughput in this layer. Tools like managed Apache Flink offers features like checkpointing to ensure fault tolerance in case of failures. Once your data is processed, it needs to be delivered to a destination for consumption. Depending on your use case, your destination could be a data lake such as Amazon S3 for long-term storage of raw or processed data. Secondly, it could be data warehouses such as Amazon Redshift for running complex queries. Thirdly, it could be some database such as Amazon RDS or Amazon DynamoDB for transactional processing. It could also be OpenSearch for real-time search and analytics. Lastly, you could also consider event-driven applications built on AWS Lambda or Amazon SQS SNS. Choosing the right destination depends entirely on your use cases. If you're building a real-time dashboard, you'll likely use OpenSearch or Redshift. If you're storing data for long-term analytics, a data lake on S3 makes sense. One key consideration here is to optimize data delivery to these destinations by using Amazon Kinesis Firehose, which automatically scales and buffers data before sending it to the downstream service. This ensures minimal latency and optimal resource utilization. Let's talk briefly about some advanced use cases and scalability considerations. For large-scale systems, multi-region deployments using AWS Global Accelerator or AWS Transit Gateway can ensure low latency and highly available streaming architectures across different geographies. You can also use cross-account access and VPC peering for integrating multiple AWS accounts or regions seamlessly. For industries like IoT, streaming architectures help manage billions of events per second from devices globally. The ability to store, process, and analyze this data in real time means businesses can unlock new opportunities like predictive maintenance, location based services, and even autonomous systems. When designing such architectures, always consider fault tolerance, horizontal scaling, and cost optimization. Use auto scaling for stream processing components and configure CloudWatch alarms to monitor performance in real time. That wraps up our discussion on modern data streaming architectures on AWS. We have covered everything from data sources that generate a stream to the ingestion, storage, processing, and finally, delivery of that data to its destination. If you are building real time analytics systems, event driven applications, or even an IoT solution, understanding this architecture will help you design a scalable, resilient, and efficient systems on AWS. Feel free to like, subscribe, and comment if you found this content valuable. Thank you for watching, and I'll see you in the next video.